Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss modeling with differential equations. Let's do this example. Find the value of m for which y equals e to the mx is a solution to y prime plus 8y equals 0. Solution. So what we're going to do is we're going to take our function y equals e to the mx, and we're going to make sure that it's a solution to this differential equation. We have to differentiate it and then just plug it into our differential equation. So y prime is equal to, the derivative of e to the x is e to the x, but here we have e to the mx. So we're going to use the chain rule. So we take the derivative of the outside and evaluate it at the inside. That gives us e to the mx times the derivative of the inside. M is a constant, and so when you differentiate x, you just get 1. So we're left with m times 1, which is just m. So this is really y prime equals m times e to the mx. Now that we have y and y prime, we can plug them into our differential equation. So our differential equation was y prime plus 8y equals 0. Replacing y prime with m e to the mx. Then we have plus and the 8, and then replace the y with e to the mx. And this should be equal to 0. It looks like we can factor out e to the mx because we have one copy of e to the mx in each term. So let's pull it out. So we have e to the mx parentheses, and let's see, e to the mx times what is going to give us m e to the mx? Well, m. Then plus, and then e to the mx times what is going to give us 8 e to the mx? Well, 8. This is equal to 0. Because we have a product and it's equal to 0, you basically set each factor equal to 0. You get e to the mx equals 0, or m plus 8 equals 0. E to the mx can never be 0, so we ignore that. And so m is equal to negative 8. And so that would be the value of m for which y equals e to the mx is a solution. Remember, for y equals e to the mx to be a solution to the differential equation, it basically means if we plug it in, the equation is true. And that's what we've done. We took the first derivative, we replaced y prime with the first derivative and y with the function, and we ended up solving for m. Okay, let's do a different type of problem. Let's do this problem, which is very interesting. It says a cup of hot tea with temperature 94 degrees is placed in a room with temperature 21 degrees. Newton's law of cooling states that the rate of cooling is directly proportional to the temperature difference between the object and its surroundings. Express this as a differential equation. What is the initial condition? Wow, that's a lot to read, so let's go through it carefully. Solution. So first, let's clarify what we mean by directly proportional, because that is super important in order to understand the solution. So recall, if someone says y is directly proportional to x. So if someone says y is directly proportional to x, that means that y is equal to a constant k times x, where k is called the constant of proportionality. So y is directly proportional to x, y equals k times x. So you basically put an equal sign and then multiply by a constant, and then you have your x. All right, we also need some variables here. We need a variable for the temperature. So let's let big T of little t, let's let this be the temperature. So temp at time little t. In this particular problem, it would be the temperature of the hot tea at, let's say, t seconds. So let me go ahead and put seconds here. Seconds. Okay, now we're ready to write the differential equation. It says up here, it says rate of cooling. So that's the rate of change of cooling. So that's going to be the rate of change of big T with respect to time. So rates of change are derivatives. So the rate of change of big T with respect to time is going to be dt dt. This is how fast the temperature is changing. It's the rate of change of the temperature. And it is, so it is means equals, directly proportional, that's where we get the K from, to the temperature difference between the object and its surroundings. So parentheses, the temperature of the object we said was big T, and minus the temperature of its surroundings. So it's placed in a room with temperature 21 degrees, it says. So that's going to be the temperature of the surrounding area. That's going to be the differential equation right there. dt dt is equal to K times T minus 21. It also wants the initial condition. So the initial condition is the initial temperature of the object, which in this case is a cup of hot tea. The first sentence says, a cup of hot tea with temperature 94. So that would be T of 0 is equal to 94. So this would be the initial condition. Really a nice problem. And this differential equation is not hard to solve. We won't solve it, but at least I'll give you some insight into how to solve it. Basically, you would just divide by T minus 21. So you would get dt over T minus 21. And that's equal to, multiply by little dt, you get K dt. Then you integrate both sides. You're going to get a natural log here, etc. So very straightforward to integrate. Kind of a nice problem because it lets you turn a word problem into a differential equation. So it's, it's modeling with differential equations. And this is a model that you can actually test. In this case, we use hot tea. You can use a loaf of bread. You can put something in the oven and take it out, and you can actually test Newton's law of cooling if you want to. Just be careful if you do that. So anyways, I hope you've enjoyed this video, and hopefully you've learned some mathematics. If you enjoyed this video, make sure to check out more videos on Chegg. Good luck.